Good evening, everyone. I'm Helvi Joy Deluvio. My topic is about genetic testing for hemostatic disorders. High throughput genetic sequencing has become the reference approach to identifying the genetic variants that underlie platelet related and coagulopathy related bleeding disorders, having replaced the pioneering but less precise Sanger sequencing since 2007. High throughput sequencing is also known as the next generation sequencing is a comprehensive term used to describe technologies that sequence DNA and RNA in a rapid and cost-effective manner. Sanger sequencing is also known as the chain termination method is a method for determining the nucleotide sequence of DNA. The method was developed by two-time Nobel laureate Frederick Sanger and his colleagues in 1977, hence the name the Sanger sequence. The difference between the two, the high throughput sequencing and the Sanger sequencing is Sanger sequencing can only sequence a single fragment at a time, while high throughput genetic sequencing can sequence millions of DNA molecules simultaneously. This is Table 41.8, which illustrates the genetic variants whose presence has been definitively identified with the listed coagulation disorders. In this first column is the variant, the second is the coagulopathy, and the mode of inheritance. First is factor 2, the prothrombin deficiency. The factor 5, factor 7 deficiency is an autosomal recessive. Factor 8, hemophilia A coagulopathy. Factor 9, hemophilia B coagulopathy is an X-linked recessive. Factor 10, factor 11, and factor 13A1, factor 13B deficiency is an autosomal recessive. FG4, FGB, FGG fibrinogen deficiency is an autosomal dominant and autosomal recessive. LMAN1, MCFD2 combined 5 and 8 deficiency are autosomal recessive. The prekallikrein Fletcher factor deficiency, kininogen Fitzgerald factor deficiency is an autosomal recessive. Von Willebrand disease is an autosomal dominant. Plasminogen deficiency is an autosomal recessive. Plasminogen activator inhibitor 1 deficiency, multiple coagulation factor deficiency type 1, and multiple coagulation factor deficiency type 2 are autosomal recessive. High throughput sequencing is being developed as a clinical assays and may include whole genome sequencing, whole exome sequencing, and gene-targeted methods. The first method is the whole genome sequencing is a comprehensive method for analyzing entire genomes. Genomic information has been instrumental in identifying inherited disorders, characterizing the mutations that drive cancer progression, and tracking disease outbreaks. Second is the whole exome sequencing is a type of genetic sequencing increasingly used to understand what may be causing symptoms or a disease. Genetic testing has already been used for a long time in some health areas such as cancer diagnosis and prenatal screening. Third is the gene-targeted method is a process of altering a specific sequence or gene at its location in a genome. Potential modifications include deletions, insertions, or replacement of endogenous sequence with alternative sequences. Sequencing can cause continually decline, and it is likely that whole genome High-throughput sequencing will become the clinical standard, gradually replacing inherently imprecise phenotypic assays such as the time-honored platelet function testing, quantitative platelet activation immunoassays, and clot-based coagulation factor assays. Bes- Besides the currently known hemostatic variants, high-throughput sequencing extreme precision enables the detection of many additional variants whose provenance requires a statistical comparison with the current phenotypic methodology and clinical outcomes for disorders currently unnamed are identified by trivial nomenclature. This effort has produced phenotypic ontologies or formal naming systems more precise than the International Classification of Diseases 10th revision, such as the Human Phenotypic Ontology, leading to further platelet and coagulopathy disorder associations and to consolidations of terminology. That's all. And thank you. God bless.